Hi, welcome back. This is going to be a short video that's going to cover the acid section of the OCR A-Level Chemistry. And so in that we've got to look at some formula of some common acids, strong and weak acids, we'll look at neutralization reactions, and then some titrations, specifically titration calculations. So first up, let's look at some common acids. And the ones they recommend that you know is HCl, or hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid, and CH3COOH, which is ethanoic acid. So what happens to especially these top three is, or all the acids, is they donate protons, which in this case is a hydrogen ion. A hydrogen ion, think of hydrogen of having one electron. A hydrogen ion, where it's lost that electron, has no electrons at all, so it's sometimes referred to as just a proton, because that's all there is in there. So all of these donate that proton. So in hydrochloric acid, we get H plus and Cl minus. In sulfuric acid, it can donate two hydrogen ions, so it gets 2H plus, so the H2 there. Nitric acid, just a single one. Now, all of these three are declared as strong acids. They completely dissociate. So if we add any of these to water, this is the resultant we get. All of these become dissolved in water, so we'd have aqueous after each one of those. Now, ethanoic acid is a weak acid, so something slightly different happens. So first of all, yes, it can dissociate, and we get our conjugate base and H plus, so that's it dissociated. But then these come back together, so that H plus can then rejoin with that minus and go back to form ethanoic acid. So it's got a unique arrow going backwards and forwards to represent that it's going this way and that way, and it's in equilibrium. It's going this way just as much as it's going that way, and this is a sign that it's a weak acid. So these completely dissociate, so all three of these are strong acids. This one, just a weak acid. And you'll see different versions of these all through the course. So that is just covering, that's covered formula of common acids and also strong and weak. So that's A and B over the course. Next up is neutralization. And in neutralization, we're going to take our acid, in this case HCl, I'm going to react it with an alkali. And we form from this a salt, NaCl, and H2O. And if we ignore the Cl and the Na, we're going to form our salt. We've got here H plus with OH minus, so our acid, our alkali, and that is going to form our water. And that's simply where everything comes from, the basis of neutralization reactions. Here we have a salt, always useful to know and identify salts, and this is where we've replaced the hydrogen ion, or the proton, on an acid with a metal ion or ammonium. This can also be, if we're going to do, we can also use this to look at titration calculations. So titrations are a way we can find out the concentrations of unknowns. So let's say we wanted to know what the concentration of this unknown HCl was. So in order to find that out, we're going to take and measure out a set amount of HCl. I'm going to take 25 centimetres cubed. I'm going to put it into a conical flask. So I know the volume I've got, I just don't know how concentrated it is. Then I'm going to get my sodium hydroxide, and this time I'm going to make sure I do know. This is the standard I'm going to use to titrate against. I do know the concentration of this. So that's 1 mole per decimeter cubed. Now, I'll put this in my burette and I'll add drop by drop by drop until it's neutralized, and then I'll have a volume reading. I'm going to make the maths easy for myself there. So I've got a volume there of 20 centimeters cubed. So I can look at this. I want to work out what the concentration is here. I'm at the end point of my titration, and that's the point where the HCl's are balanced with the NaOH's. And we can use their stoichiometry then to work out each of their number of moles. So the first thing I can do is, I can't do anything with a HCl because I only know one thing. But I do know two things here. So here, if I call this step 1, I can work out the number of moles here, which is C times V. I'll have to divide by 1000 because it's in centimetres cubed, and that will give me 0.02 moles. Now if I know this, I can also use the stoichiometry to work out the number of moles of HCl there were, and this is a 1-to-1. So I've also got 0.02 moles of the HCl. And then I can rearrange this equation to make concentration the subject and do N over V times 1000 gives me, I'll get a calculator for this, 0.02 divided by 25 times 1000 equals 0.8, and now this is a concentration, so that's moles per decimeters cubed, or moles divided by the volume, which we see here is what we do in the calculation. We take the moles and divide it by volume, and the units tell us that as well. So that is a titration calculation.